Hello everyone, we are Team 3 and I am the first presentation, Jo Young-jun, who will present the front part of this presentation. Then let's start the presentation about Lotte World Tower. This time, we will talk about engineering issues in design and the foundation more detail. This part will be divided into three parts: design, curtain walls, and wind resistance. Since Lotte World Tower is a skyscraper that would be a landmark of Korea, it was very important to add elements in design that could represent Korea. However, it was never easy to create a future-oriented symbol of Seoul's growth and Korea's technological advancement, while at the same time melting Korean traditional culture and unique sense into the building. During the 27 years of the project, most of the major domestic and foreign companies proposed a variety of design over 20 times, but most of them failed to incorporate cultural elements into the design. After a number of reviews, Lotte finally adopted the current design based on the curvature of Korea, which is not just one symbolic object, but one that encompasses all of them. And mostly, its design is motivated by the shape of pottery and brush. So, a lot of curtain walls are used to express the soft line and two lines of notch section. John Gustafson, president of Curtain Wall Consulting, said that he had worked on many curtain walls, but nothing was as difficult as Lotte World Tower in terms of shape. In Lotte World Tower, argon gas high insulation double glass was installed and it has 28 mm of thickness in total. 12 mm of argon gas, 8 mm of tempered glass, and low E coating, which makes it strong enough to hold vertical gravity and increase the thermal efficiency moreover. There are 21,000 units, and each unit weight has as much as 600 kilograms. What's more surprising is that these shapes are all different. As you can see in the picture, as the building is sloping upwards, all the points of the unit are marked on the entire floor of the slope section, depending on the height, width, and corner angle of the unit, which requires a high level of precision construction. And another issue is its wind resistance design. Lotte World Tower was designed to withstand maximum instantaneous wind speeds up to 128 meters per second. A series of wind tunnel tests were conducted and the results were reflected in the structural design. According to research paper, after 50% schematic design stage, a high-frequency force balance test was conducted, and the analysis was done twice at the end of the design development and after the 60% DD stage. During the 90% DD stage, when most of the dynamic properties were identified, an additional aeroelastic model wind tunnel study was conducted after 50% SD stage and after the 90% DD stage, respectively. After the test, it was found that wind loads calculated from the aeroelastic model study were 17 to 22% lower than that from the high-frequency force balance test, and the base shear was also lower than that from the HFFB test by 15%, as you can see on the table. According to a wind load expert, the aeroelastic results can be more favorable because the aeroelastic experiment reflects its aeroelastic effects to the model just like aerodynamic damping effects. As a result, Lotte Tower was built being satisfied with its acceleration limit and torsional velocity limit.
Hello, I'm Jasok Che. Today I'm going to talk about constructional issue analysis of Lotte World Tower. I'm going to explain about foundation part. Before starting foundation construction process of Lotte World Tower, subsurface exploration were carried out. First of all, before foundation construction, precise analysis of ground were taken place. Especially, this process was really important because Lotte Tower is high-rise building, and therefore the result of this analysis can affect subsequent process, such as selection of ground improvement method and foundation method. In this process, four analysis methods were carried out. Firstly, core sampling analysis. Secondly, face mapping. Thirdly, resistivity exploration. Lastly, plate bearing test. These four methods were used to measure bearing power of solid and constructional considerations. Through data obtained from this method, construction team could consider features of size ground and finally apply them in mat foundation process. And then ground improvement work were carried out. Construction team dig under 38 meter and carried out ground improvement work by driving 108 PRD piles that has 1 meter of diameter onto these bedrocks. And this cast-in-place piles has 60 megapascal strength. The main purpose of this work was to prevent subsidence of foundation and to reduce unequal settlement rate. After ground improvement work, foundation process was carried out. In Lotte Tower construction process, mat foundation was applied. Before talking about Lotte Tower's case, I will explain about mat foundation. Mat foundation is footing which has continuous thick concrete slab on the soil that extends the entire footprint of the building and increases the soil bearing capacity power. Since it can support the entire building loads and safely transfer it to the ground, it is suitable for heavy building construction or ground that has low bearing capacity. And main advantage to this method is that it is stable foundation to unequal settlement. This is the introduction of mat foundation that applied in Lotte Tower. Its scale is 32,000 cubic meters and its casting time was about 30 hours. Consecutive concrete casting was applied during the casting process, and especially ultra-low heat concrete was used, which has 50 megapascal of strength. And lastly, large high-tension deformed bars were used. In this process, mainly four methods were applied. First of all, cut-off wall, and secondly, consecutive concrete casting. For thirdly, design of ultra-low heat concrete, and lastly, application of high-tension deformed bars. And first main process of mat foundation was inserting cut-off wall around the Lotte Tower site. Cut-off wall means a wall surrounding excavation site or foundation that is used to exclude groundwater from sites. This cut-off wall can be made of various ways, such as steel sheet filing or concrete diaphragm walls, and so on. In this case, concrete cut-off walls around Lotte Tower site were inserted into bedrock to eliminate any possible infiltration of groundwater. These walls have 27 meters depth and 1 meter thickness. This is a short video of cut-off wall that surround the building. As you can see, these walls surround the entire buildings to keep buildings safe from groundwater. Second main process of mat foundation of consecutive concrete casting. Because among the casting methods of concrete, consecutive casting is best weight for durability and strength performance of concrete. Since Lotte Tower was high-rise building with tremendous scale, consecutive concrete casting was needed for stable foundation. To succeed this way, tremendous amount of concrete was needed. In fact, 5,300 number of Remington trucks were hired. An amount of concrete used in this meth foundation was 80,000 tons, and the scale is 2.5 times bigger than that of Burj Khalifa's meth construction. And for the first time in Korea, 32 hours of consecutive casting was completed. This is a time-lapse video of consecutive concrete casting. Not only that, in this mass concrete work, one of concrete chemical reaction called hydration reaction can cause thermal cracking, which can occur due to excessive temperature differences within concrete during mixing and casting process. This can induce lowering of concrete performance. So there were rigid requirements for mass concrete in foundation. These are requirements. To satisfy these requirements, Lotte ENC and Asia Cement collaborated. And after 2 years of collaboration work, special ultra-low heat cement mix was invented. According to experiment of hydration temperature measurement, the concrete using this cement that fulfilled design strength 50 megapascal had 50% lower maximum temperature compared to normal concrete and fulfilled the other design requirements. So this special ultra-low heat cement was used entire meth foundation process. Finally, construction team used super high tension deformed bar in meth foundation. If we assault deformed bars by yield strength value, there are mainly three types of bars: HD, SHD, and UHD. Among these bars, HD bar that has 51 mm diameters were used at first in Korea. Construction teams located HD bars on site. They coupled each located bars to BMS bar, the mechanical coupling method of steel bars. An entire weight of bars was 4,200 tons. Thanks to this method application, Met foundation of Lotte World Tower was successfully constructed. It has roughly 1.8 times bigger than that of Burj Khalifa and 8,000 tons of high-strength concrete. That is more than 2.5 times the amount of Burj Khalifa. This is our goal. And this is our weekly study plan. Thank you for listening.